Okay, function key features day 2. So now we're going to talk about different types of symmetry. So there's line symmetry, where the graph can be folded in half and the two halves match. Or there's point symmetry, where it remains unchanged if you rotate it 180 degrees, about a point. So the x-axis and the y-axis are common lines of symmetry. So those are mostly what we'll be working with. And the origin is a common point of symmetry. And the origin is where the x and the y-axis cross, so that middle point. Okay, so tests for symmetry. The graphical test, for every point xy on the graph, the point x negative y is also on the graph. So basically, if it's symmetrical with the x-axis, that means you can fold it downwards over the x-axis and it will line up perfectly. Okay, we'll get more into that and it'll make more sense. Algebraically, you replace y with negative y and it should result in an equivalent equation. Okay, for the y-axis, you should get negative x and y for every point xy, and you replace x with negative x. Okay, and for the origin, you replace, it should be negative x and negative y, and you replace y with negative y and x with negative x, so you do both, and it should get the same equation out. Okay, let's go through that. So just looking at graph A, we can tell that this is symmetric with that line right there, which is the y-axis. Okay, now we're just going to confirm our answer algebraically. So for the y-axis, we have to replace every x with negative x. So I'm going to have y equals negative x to the fourth minus 4 times negative x squared. Well, negative x to the fourth, that's negative x times negative x, which is positive x, times negative x, which is negative x, times negative x again, which is positive x. So that's positive x to the fourth. And then negative x squared is positive x squared, which is the same equation from before, so we're good. That works. It is symmetric with the y-axis. And that's a line symmetry. Since it's symmetric with the y-axis, it's symmetric with a line. Okay, let's look at example B. So this is not symmetric with the x-axis, because if we fold that, it doesn't do anything. It's not symmetric with the y-axis either. So let's check origin. Let's rotate this 180 degrees, and we get the same exact graph. So it is symmetric with the origin. Whoops. Now, what is happening? Sorry. Because my foot was touching it. Yeah, never mind. Okay, but it is symmetric with the origin, so we're going to check this algebraically. So I'm going to have to replace my y with negative y and my x with negative x. So this becomes negative x times negative y equals 6. A negative times negative is a positive, so that's xy equals 6. It's the same exact equation I started with, so that was correct. Smiley face, awesome. Okay, let's look at C. This is not symmetric with the y-axis, because if I fold over that, it's not going to do anything. It is symmetric with the x-axis. So I'm going to check this by replacing my y's with negative y. So I have 4 times x plus 3 squared plus negative y squared equals 16. Negative y squared is positive y squared, which is the same equation, so we're good. Okay, let's look at example D. So this is symmetric with the x-axis. It is also symmetric with the y-axis. And it is also symmetric with the origin, because if we rotate that, we're going to get the same exact graph. So that means I have 3 different things I'm going to check. I need to check my x-axis. So I'm going to replace my y's with negative y. So that's negative y squared minus x squared equals 1. Negative y squared is positive y squared. So that's the same, we're good. It is symmetric with the x-axis. Now let's check y-axis. So I have to replace my x's with negative x. So I have y squared minus negative x squared equals 1. Negative x squared is x squared, so that's y squared minus x squared equals 1. Now the origin, so I have to replace with negative y and negative x. So So I have negative y squared minus negative x squared equals 1. Negative y squared is y squared. Negative x squared is x squared, and that equals 1. We're good. Cool? These last two, I'm just going to put up the answers. So E, that doesn't have any symmetry, and F, that is symmetric with the y-axis. And you can check those algebraically also. Okay? Now let's get into even and odd functions. So a function is even if it's symmetric with the y-axis. And the way you check this is you plug in negative x for your f of x, and it should equal. So again, something's happening, I don't know. But you plug in negative x, and it should equal f of x. Okay? And a function is odd if it's symmetric with the origin. So you plug in negative x, and if it equals the very opposite of what you started with, then it's symmetric with the origin, and it's odd. Okay? Let's go through these so we can get them. So you always check these by plugging in negative x. So I'm going to have f of negative x equals negative x cubed minus negative x. Negative x cubed is still negative x cubed, and a negative times a negative is a positive, so that's negative x cubed plus x, which is negative f of x, so that function is odd. Okay? Let's look at b. I'm going to plug in negative x for that. Negative x squared is just x squared, so that's negative x squared plus 6, which is the same thing we started with, so that is even. Okay, let's look at c. Plug in negative x again. So we have negative x cubed minus negative x squared minus 2 times negative x. When you simplify that all down, you get negative x cubed minus x squared plus 2x, which is not the same that we started with, and it's not the complete opposite of what we started with either. So that's neither. It's not even or odd. Okay, let's look at D. So I'm going to plug in negative x again, simplify that down, and I'm left with x squared minus 4, which is the same thing that we started with, so that is even. Okay, let's look at E. So we have negative x over, or negative 8 over negative x. A negative divided by a negative is a positive, so we get 8 over x, which is the opposite of what we started with, so that is an odd function. Okay, then this last one, we have f of x equals the absolute value of negative x plus 1, which is just negative x plus 1, which is not the opposite, it is not the same as what we started with, so that is neither. Okay, this is the last video for this unit. Please remember to take the quiz, and I'll see you guys tomorrow.